4 human beings are hurtling through space at over 39,000 kilometers per hour. The moon is getting larger in the window. Earth is shrinking behind them. And in about 30 minutes, every single radio signal between them and the rest of humanity will go completely silent. This is Artemis II. And what the crew is actually doing up there is far more extraordinary than anyone is telling you. Most people who followed the launch know the basics. 4 astronauts, an SLS rocket, a 10-day mission around the moon, the first crewed deep space mission since Apollo 17 in 1972. But those headlines are missing the part that should genuinely terrify you and inspire you in equal measure. Let's go deeper. Artemis II is not a moon landing. The crew doesn't touch down. They don't plant a flag. They don't walk on the surface. They do something arguably more important. They fly past the moon, closer than most crewed spacecraft have come in half a century, and then they come back. So why is this the most important crewed spaceflight since the Apollo era? Why does the mission exist at all? And what are 4 human beings actually doing for 10 days in deep space? Here's the thing most people miss. Every system on the Orion capsule is being evaluated for the first time with living, breathing humans inside it. Life support, deep space radiation exposure, communication relay systems, navigation at 250,000 miles from home, thermal control in the extreme temperature swings of deep space, more than 200 degrees difference between the sunlit face and the shadowed face of the capsule. Artemis I tested all of this with no crew inside. Artemis II tests it with people. That is the entire point of this mission, and the 4 people doing it are not simply test subjects. They are the architects of every mission that comes after them. Let's break down exactly what the mission does, phase by phase, because this is where it gets genuinely extraordinary. The launch is the first miracle. The Space Launch System is the most powerful rocket ever successfully flown, more thrust than the Saturn V that sent Apollo astronauts to the moon. Within 8.5 minutes of liftoff, the crew is in low Earth orbit. Within 2 hours, the upper stage fires again. This burn is called the Translunar Injection, the TLI. It is the moment Orion leaves Earth orbit entirely and begins its journey toward the moon. At Translunar Injection, the crew is traveling at 10.8 kilometers per second. And they will coast, engines completely off, for the next 4 days, pulled gradually toward the moon by its own gravity. Now here is something that most mission explainers skip entirely. The trajectory Artemis II follows is called a free return trajectory. This is one of the most important concepts in crewed spaceflight. It means the physics of the route are designed so that if nothing works, if the engine fails, if communications fail, if something goes catastrophically wrong, the spacecraft will still loop around the moon and return to Earth on its own. Gravity does the work. No engine required. The moon's gravity curves the path. Earth's gravity pulls the capsule home. This is a passive rescue plan, built directly into the laws of physics. You may have heard of Apollo 13, when their oxygen tank exploded en route to the moon.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
In 1970, it was the free return trajectory that saved their lives. They didn't fight the physics. They rode them home. Artemis II uses the same principle, a lifeline written in orbital mechanics. During the 4-day outbound coast, the crew isn't simply waiting. They are running continuous system checks, testing communication, links through NASA's Deep Space Network, a series of enormous radio dishes in California, Spain, and Australia that track the capsule across half the solar system. They are evaluating life support under real metabolic load, real breathing, real body heat, real CO2 generation, and they are being studied. NASA's Human Research Program tracks every measurable health metric during the mission: heart rate, fluid distribution, bone density markers, sleep quality in a deep space radiation environment. The data collected from the bodies of these 4 people will directly shape the health protocols for every crewed mission that follows. Then comes the moment the mission is named for. The lunar flyby. The capsule swings around the far side of the moon at a closest approach of roughly 9,200 kilometers. But before it gets there, contact is lost. For approximately 30 minutes, the crew is on the far side of the moon. No radio signal reaches Earth. No signal reaches them. The lunar body blocks all communication entirely. The crew is isolated, more completely than any human beings alive. No voice from mission control. No data feed. Just the 4 of them, the Orion systems, and the surface of the moon slowly passing below. And here is something almost nobody talks about. From the far side, Earth is not visible at all. The crew looks out their windows and sees nothing but the moon and absolute darkness. No blue horizon. No planet they have ever called home. Just a gray, ancient, cratered wilderness, stretching in every direction, and beyond it, stars. 24 human beings in all of history had ever witnessed that view before this mission. Artemis II adds 4 more. After the flyby, the free return trajectory curves the capsule out to a maximum distance of approximately 370,000 kilometers from Earth, among the furthest points any human beings have ever traveled. Then gravity pulls them back. Another 4-day return coast, more system checks, more physiological data, and then comes the moment that carries the highest stakes of the entire mission. Re-entry. The Orion capsule hits Earth's atmosphere at nearly 40,000 kilometers per hour. The heat shield, the largest ablative heat shield ever built, absorbs temperatures approaching 2,760 degrees Celsius. For context, that is hotter than the outer layer of the sun's surface. The shield does not just block this heat. It burns. The ablative material chars and flakes away, carrying thermal energy with it, protecting the capsule and crew behind it. If the heat shield performs below tolerance at those speeds, there is no recovery. The crew does not survive. That is precisely why Artemis II exists. Not to land on the moon, to prove, under real conditions with real people, that every link in this chain works. Before anyone attempts the landing, if this kind of deep dive is changing the way you see what's happening up there, hit subscribe. We break down complex missions like this every single week. Don't miss what comes next in the series. So what happens if Artemis II succeeds? Artemis III, a lunar landing. The first humans on the surface of the moon since December 1972. The first woman, the first person of color. Not a brief surface excursion, an extended stay using the SpaceX Starship human landing system. Boots on the regolith, tools deployed, samples collected. Real scientific work on the lunar surface. But the vision doesn't stop there, and this is where the story becomes something far larger than any single mission. NASA and its international partners are building something that has never existed before: permanent infrastructure at the moon. The Lunar Gateway is a small space station that will orbit the Moon itself, not Earth. The Moon. Constructed with contributions from the United States, Canada, Europe, and Japan, astronauts will live aboard it for weeks at a time. It becomes the staging post for all future surface missions, a refueling point, a research hub, a deep space communications relay. On the surface below, the plan includes pressurized habitats where crews can spend multiple days at a time, equipment cached between missions, resources left in place and ready for the next team. What makes all of this possible, financially and physically, is one discovery beneath the lunar South Pole: water ice. Confirmed water ice, trapped in permanently shadowed craters that have never seen sunlight in billions of years. Water means oxygen to breathe. Water means hydrogen and oxygen, split by solar-powered electrolysis, which means rocket propellant. The Moon could, in theory, refuel spacecraft departing for Mars. It transforms the economics of the entire solar system. A petrol station, 250,000 miles from Earth. But there is another player in this story, and this is where the mission becomes a geopolitical one. China's Chang'e program has systematically mapped the lunar South Pole with orbiters and rovers. China and Russia have announced joint plans for the International Lunar Research Station, targeting the same southern polar region that Artemis is aimed at. 2 space programs, 1 location. Both understand exactly what the water means. The Artemis program exists, in part, to establish a durable American presence at that location before the geopolitical window narrows. Artemis II is the opening move, a demonstration visible to the entire world that the U.S. can place human beings in deep space and bring them back safely. The signal matters as much as the science. And beneath all of the engineering, the politics, and the mission architecture, there is something harder to quantify. The crew of Artemis II will look back at Earth from 370,000 kilometers away. They will see it the way almost no human being in history has ever seen it. A small sphere, a single pale object floating in a black void. No visible borders, no trace of anything that happens down on its surface. No conflict, no division, just one fragile ball of rock and water and atmosphere, suspended in silence. Every astronaut who has described this perspective uses almost the same words. Something changes, permanently. The scale of what matters and what doesn't looks completely different from out there. 28 human beings in the entire recorded history of our species will have experienced that view by the time this mission returns. 28. Artemis II is not just about the Moon. It is the first chapter of a far longer story. A story that points toward Mars and eventually beyond. But it starts here, with 4 people in a capsule the size of a large van, swinging around the nearest world we have ever known, and proving that what once seemed impossible is just engineering. If you found this useful, hit subscribe. We post every week.